Hello, I'm Chris Athanas. I'm a KMP developer. Last time I checked, tech support gave me a call and they said they were coming out on Tuesday. So hopefully that'll be closed up soon, the bane of my existence. We're getting into software design. So what is software design? The big idea. Can we use drawings and diagrams to visually communicate about software designs? Can we do that? Because the problem is you may understand it, but trying to communicate to other people, it can be a problem because people have different styles of learning, right? They have different styles of learning. So some people are auditory learners. That's why a lot of people are attracted to computers and languages and stuff like that. So you'll have people that are like really are very comfortable just hearing something and having build a model in their mind, a visual model, a verbal model actually. But other people are very visual like me. I'm a very visual person, and I get really confused because software you can define things in lots of different ways, and it's knowledge work. So we're trying to work through these things and convey ideas and concepts. Because at this point, we're getting above the hardware. Now we're in the computer science land, which is more like should have been called organizational technology, like how we can the organizational theory, like how can we organize things in the most efficient way possible, and to get to for a specific problem. And unfortunately, there is no standard way of doing this. Let's get into it. That's episode 2. Let's do this one. Episode 2. Is this it? No, this is episode 1. We want episode 1. Go here, dear. So here we go. So go give him a like and subscribe, Ian Crossland, Jonathan Crossland, not Ian Cross, Jonathan Crossland. This guy's great. His channel is tiny, but this content is gold. Like I wish somebody would have told me this stuff when I got started.
Hi, my name is Jonathan, and welcome to Designing from the Beginning. So what we're going to do is go over, it's kind of like a beginner's course, to intermediate to advanced. So we're going to start here right at the very, very beginning and talk about design. So there's a lot of confusion as to what is software design, design patterns, architecture. There's confusion only in the sense that,
I just want to notice it's number 0. So this guy is definitely a programmer, and he knows that you can always count from 0. All right, I'll stop it.
Design patterns, architecture. There's confusion only in the sense that, being pedantic, right? Or people's understanding of what they do, pragmatically what they actually do in order to achieve something and what that might mean. And people will reason about it in different ways. People might say that it's abstract, that it's all sort of ambiguous kind of things. Some people might argue it's process. Some people might argue it's the output. It's the things that you actually put together and glue together. Overall, the design process for any industry is largely undefined.
So all these efforts to standardize and put a system in place and we could just do it the right way. Unfortunately, knowledge work does not apply. That does not apply. It's inherently risky because we may not actually find the proper good solution in the time we're given. Yeah, that's the main risk. Not all this technical implementation stuff. Is have we defined the problem and the solution well enough so it supplies value in the time allotted, in the time we've allotted to build this thing. So getting down to what are we doing? What are we building? How are we building it? And what's important, what's not important. This is what this is about. So now we're above the hardware. The hardware implementation, that's more or less an implementation detail at this point. And now we're like, okay, how do we organize the work and organize the problem so we can have a solution that actually provides value to us, humans? Yeah.
Is a human endeavor. And being one human endeavor has certain qualities bestowed on it that is kind of abstract in thought, abstract in ideas and creativity.
Abstract meaning general. Anytime you hear in the computer world, when you hear the word abstract, it does not mean like in the art world. It's something abstract, like this bizarro, strange land, which when I first heard this word abstract, it's like, are you talking about that stuff? It's like, no, they're just saying the general case. And the thing is, I've talked to, when talking to people, like I'm a curious guy. I'm all over the place. They don't see that there's there's another meanings to these words. Abstract means like in philosophy, it's like this a general, not even general case. It's like this other thing that's not even doesn't even apply to the computer world of general. So this is really frustrating because I've encountered people who didn't realize there was other definitions for that word, and I was getting really confused talking to them about what are you talking about here? And all the guy had to say was, I just mean general case. That's all I mean here. And when you're talking to computer people and they say abstract, they're not talking about art. They're not talking about philosophy. They're just talking about the general idea of something. Gotta use the word abstract.
And while it's true, many industries are very, very technical and have real science behind them. In order for proper design to take place, whether that's the design of the product cover, the casing, whether it's a user experience or a process, all of these things are going to take feedback, it's going to take iterative approaches, and it's going to take a certain level of skill.
Right, so iterative approach. That's the whole point. You can't plan the stuff ahead of time. You try to do it, it'll just make make everyone's life complete nightmare. And the project is actually at that, when you start to do that kind of stuff, planning out time estimates, how long it's going to take to do everything, without bringing the feedback in, you may get it on time. You may get that project on time, but it's not going to be what you want. Not these days. That's just, you can't deliver software like that. Well, very small, very narrow cases, but in general, when you're building something new, it's knowledge work. So we're exploring these spaces.
Okay, so let's get started. As I said, I want to get started right from the very beginning. So if you know anyone who is getting into software, or is in their first couple of years of software development and needs to understand the basics, the fundamentals, make sure that there's no gaps in their understanding, this is probably the video series.
Yeah, he's right. So you're lucky that I picked up to this guy because he's only got 400 subs, but he's on target. He's straight up all like bombing the hell out of the target with this stuff
for them. So I would welcome if you recommend it to them, bring them along. Let's see if it's helpful to them. We're going to start with the first law of software design, and I've got a t-shirt with it. I feel that strongly about it.
I thought he was going to say I got boobs.
I'm not American, so I don't put everything on t-shirts, only very, very specific things. Let's talk about the box. Okay, so the box, there it is. Why is this the first law? It's the first law because it represents a list of things. And I can easily go and say this is a vehicle, and I can draw another box and say this is a truck. And I can draw another list and say this is a cat. And if I'm building a system, it's pretty helpful to list these out. And I could create a list such as that, of course. But dragging these things around and moving them and saying, well, that's kind of sticks together. That goes together. And perhaps drawing something around those, another box, is somewhat helpful. It's helpful to sort of create the categorization, to create what belongs together. And
yeah, this is called cohesion.
This is a concept of cohesion. So these two things belong together, this doesn't, and the idea is too different.
So cohesion and coupling are these major topics that come up because this is the kind of stuff like what belongs together, what is cohesive, what kind of makes sense inside the same area, generally speaking, in the abstract. In the general case, like how does this belong to this? Does this belong to this? That's cohesion, sticking together. Things are kind of grouped together, sticking together. Like for a cat, you'd have its weight, its size, its length, its color, its eye color, ear color. Those things ought to be together, but there might not be. There might be a reason to separate out the eye color and the weight from the cat. There might be a reason for that, for what other particular. So it's like what belongs together and what's like stuck together and what can be separated. Coupling and cohesion. Ooh.
I don't really want to put that inside there, and you can see why. I mean, it's absolutely a different thing. So we're talking about an animal, we're talking about objects here. Here we're talking about a living thing. They are different. So what am I going to call this boundary? If I create a boundary and I want to drag things in, then I have a notion of what goes inside, what fits inside of that boundary. So if I put another box down and I do something like travel, what does that mean, travel? What does it mean? Well, it's not a thing. It could be kind of an abstract concept of traveling. Maybe it's holiday. Where does it go? So maybe it's not quite the right thing to fit in here either. It's not, but it's kind of relating to traveling. Perhaps it's.
See, it was like, okay, so what are you trying to categorize? So the question is like, what are we talking about here? Are we talking about a pet delivery service? Are we talking about an ambulance service? Are we a pet food? What are we talking about? So it's like then you start to get more specific. Okay, we're doing pet delivery service or pet ambulance. That's where this is why it was like, having these graphically out like this allows people who are visual learners to engage our words with auditory learners and kinesthetic learners, so we can all get the right, we're all on the same page. Right now, what page are we on? We're getting there, right?
It's not the right word. And this is how we use the humble box to kind of get a grasp of what we're talking about in terms of categorization. The next thing we tend to use the box for is some kind of labeling. So what I might do is I might say that this truck is a vehicle. And I'm labeling that box. I can label this box, and I can say, well, this is a pet. And the label is quite useful as well because it kind of describes a quality. There are various relationships that the label and that can have. And really, I'm not talking about, a sort of a language of design here. I'm not talking about anything formal. You might have heard of Unified Modeling Language, UML.
UML, no. Yeah, so Unified Modeling Language. Yeah, they tried to push that in the 80s and 90s a lot. And they, because they were trying to wrangle this problem of knowledge work. Like, how do we all get on the same page, generally speaking? And they tried to come up with this unified modeling language, which was just a set of symbols. It's just a set of diagrammic symbols that had a certain meaning that was very specific and how to think this is what you did. It's like, no, that was a bad idea. Now the idea of symbols and drawing lines across, good idea. Having it actually mean something across domains, not a good idea. So that's why we still kind of use UML, but not in the strictest sense possible. But there's the specification. Everyone gets into the specification stuff because the actual problem of knowledge work is so difficult and taxing. We're just grabbing, trying to get a handle on this thing. And it's just like, hey, this is the risk. This is the work. Figuring out what goes where and why and how we can set this up for the most 80 IQ point solution just by configuring these things and thinking about these things in the correct way. This can either make a project win big or fail horribly. These kinds of decisions, not the code at the bottom. It's this higher level up. It's like, what are we trying to do? What does this mean? How does this mean in this context? And with this particular thing we're trying to do, that's the work. So many meetings. This is the work. If you can get the visuals, like if everyone had us on the same page about drawing diagrams like this and being visual and not just verbal or text messages or emails that people can't read, you got to get this. This gets everybody on the same page because I know this is separate from this. A truck and a cat are separate. In this particular thing, we don't have any truck cats. We don't have any transformer truck cats. But in this particular example, I now know that a truck and a cat are separate. It's that kind of stuff. It's like, because this stuff gets super confusing. When people are just talking, a lot of times they don't even 100%. They're just like working through the problem while they're speaking out loud. And we're supposed to like follow along while they're just trying to work through it. But if you're doing it like this, we can work through it together. And we both know what we're both talking about for the audits, for the verbal people. There we go.
No, I'm not talking about that. I'm not talking about any abstract modeling. I'm really just talking about what you might do on a piece of paper.
General modeling. Abstract. We got to use it abstract. Computer people love these words, man. And it is. You have to get comfortable with people that love it, because people who do language is like, oh, language. They think that it's a way of conveying power. The language is conveying a power, so of course people are going to be interested in it. And very smart people are going to get ways they know that conveying information verbally is a type of power. So this is what we're working with.
Paper, right? How you might think, and how boxes can be used to put things together. You see, I've got a boundary here. We might have many boundaries. And these boundaries might relate to each other in some way. You might get internal kind of boundaries that have some kind of crossover, some that don't. But creating this kind of box, tag, and boundary provides grouping, provides a view, some kind of zoomed in level, some kind of view of the system. And that helps us kind of group things together and understand it. Now,
and it's not just for us to understand it, but other people to understand it. It's great to work this stuff out, but when you're communicating to other people, this is the most fastest and efficient way. Yes, it's a little bit of pain in the dick to go over and do all this drawing and getting good with a Miro, but it's going to pay so many dividends because everyone will be on the same page. And that's really the biggest battle. Is not you trying to figure out the little coding. Yeah, I can't get the code right. No, it's this stuff. Oh, there's so many meetings. Well, if you would get down to the brass tacks by everyone get on the same page and doing something like these, it'll go faster. You still have to have meetings, but it'll be faster. I've seen so many people try and do this with just words, and it doesn't work that way. It works a way in their head, but they haven't understood. It's like, oh, it's communicating so other people can understand.
What we're really talking about here, to be really fair, is domain language. And I want to introduce that very, very quickly. We're going to cover it later on, but it's probably very important to understand that domain language is when you're talking about a specific kind of industry, a specific thing, then you want to use the language of that thing. So if I'm...
Yes. Super important as a programmer. We have to learn the domains of whatever business we're working, whatever service we're working, we have to use the domain language that the people who are running, they're going to be running the business and using the business and doing whatever, that has to be in that domain language. We all have to share it. It has to be a shared language, and we all have to work on what the definitions mean, and this is how you do it.
I'm using delivery vehicles, I'm delivering goods, that kind of stuff. I might not use the word travel, I might use the word logistics, for example. Right? And so the domain language is very important. We're going to get into that a little bit later. I'm going to put it over there. Okay, so the last two things, just to introduce here quickly, is generalization and abstraction, because they are
the same thing.
Absolutely fundamental to how we think about and reason about a complex design. Because complexity comes very, very quickly. If I start putting down more and more things, so let's say it's a kennel and we can have cats and dogs and goats and other forms of pets, and we're putting all of these things down, that even a bear can come here to our sanctuary, right? Our lodgings. So if this is the case, well, they're all pets, let's say, that's fine, there's a label. The cat, dog, goat, bear, it's...
So, okay, I just wanted to clarify. Okay, what he did there was remove that S off of goat. That is actually very critical. This can cause a lot of confusion. So what he's referring to is an individual item of a bear, a goat, thing. So it means one of. Anytime you put an S on the end for modern computing people, it means there's multiple. There's going to be a list. And it becomes really important because in the code, when you write the code, when you use an S, it means it's an array or list. It's going to be multiple items of some sort. And if you don't have an S on the end, it's going to mean it's a single item. It sounds very trivial, but this is something that to keep in mind, and this is why he corrected it right there, made it a point to correct it there, because it is critical important, because it's again, what are we talking about? That S, almost universally, computer people will know an S means multiple items. And if it's not an S and it's got a singular, it means a singular. It's a big deal.
Keep that singular as well. So when we're reasoning about this, we're getting into the domain language of these things. And if we keep on listing things, right, let's have a bird here as well. And we keep listing, you can see that the complexity starts growing. And complexity comes from the distinguishing of things. If I have to say, okay, I've got a pet, but what type of pet is it? Well, it's a cat. So let's say I need a report, or I need some list on screen. I need some app to say, give me a list of pets, and I need to find a dog and a goat and a cat. Well, then I need some kind of filtering or search mechanism. I need to understand the difference. So that means I need a quality, a pet, and I need a type perhaps, animal type, cat, dog. And if I'm doing a report that says, give me only cats, please, or show me all the dogs that are currently here, being kennelled, for example, then I need to make distinguishing actions. I need to say where, if I'm using SQL language, I might say, give me all the pets.
SQL is structured query language. It's just database access. It says, oh, I want to go give me cat number 486, cat ID number 684. And it'll go out and give you the cat. Or give me all the cats that weigh between 1 and 6 pounds. And it'll go get a structured query language. It's more of this crazy stuff. It's like, yes, it is a language that you're probably gonna have to know eventually at some point. It's just how to access database. How to update, read, delete. Well, my mouth, my beard.
It's where the type is dog, and that's a form of distinguishing. And the more things that I have in my code that distinguishes between things, the more complicated it gets, right? Because I'm creating associations, I'm creating connections, and creating cohesion between these things. So remember, cohesion, just to put it lightly, is what fits in a boundary. If I put a boundary over here, I could say, well, all of these things technically are cohesive. They go together. The pet is the label perhaps on this boundary, and now I'm creating.
That's all it means. cohesion and coupling also cohesion, because it is, I mean, on one level, yes, because it is important to get these distinctions right, because it'll totally screw things up if you get it wrong. It'll just make things super complicated, like if you do extra stuff and like, yeah. So thinking this through is important, and coupling cohesion is important, but the way they say it's like coupling and cohesion, it's like, yeah, it's your design of how you're gonna do your stuff. It's not a technical issue, it's a organizational issue. The computer will put whatever you want wherever you want. It doesn't care. But how we're setting it up for us, it matters.
Creating some kind of cohesion between these things. Now, generalization is something that's used to rather say, well, you know, cat, dog, goat, bear, and all of those things, well, these are animals. And I'm generalizing, right? So all of these things are animals. And I can say, well, there's my generalization. I can
Or abstraction. It's your abstraction guy.
also say they're pets, but if I say that they are pets, then I'm saying something additional. I'm saying that there are animals, but a pet is a slightly more abstract concept, right? Animals is describing that
A different type of generalization. Pets are animals. Okay,
each one of these are commonly the same. They are generally the same, and they are generally animals. They are not all generally pets, unless, of course, I'm only talking about pets. So therefore, I have a boundary that I'm kind of looking at here. The boundary of having, you know, animals that are capable of living with humans in a human environment and not harm and hurt and so on. And the definition of pet might have a gray area as well. So animal, we're never going to have any fight about that. Well, hopefully not. And we're going to say that this is a very good generalization. But
you might, depending on the context, right?
As we move from pet into other things. So let's think of another form of abstraction. So another abstraction here, top of my head, might be a thing. Okay, so a thing. So what is this thing? Well, a thing is going to be kennelled. Well, you know, kennel isn't a generalization of cat and dog, is it? Well, maybe it's too...
We just switched the context to be, okay, now we're talking about the domain of kennels. Okay, what if, are we now boarding? Are we transporting or boarding? Okay, so we just kind of did a little context switch on the domain for us.
General, right? So generalization, the more generalized you are, this is kind of a heuristic way of thinking about it, the more general you get, the more abstract it becomes. So at one point, you know, animal, cat, dog is just kind of a generalization, and then if you go into pets and to eventually a thing, you're getting a certain level of abstraction. And this is the last thing for this video. We're going to come back to the box in video 2 as well, and perhaps all throughout the series how we link all these things up. But the last thing to mention in this video is that the humble box is something where generalization, abstraction, grouping, boundaries can take place in your mind. Drawing it is very, very helpful.
Well, yeah, okay. It's not just for us, right? This is the part of one of the keys. He doesn't put emphasis on this. This is for other people. This is for other people. Yes, it is useful for visual learners like us, but other people, they don't necessarily learn this way. So it's useful for visual people. And then when you get together with kinetic and auditory learners, this is a way to communicate so everyone gets on the same page. And that's what it's all about.
And if I was drawing a domain language, a domain that I did not understand, I would have to go and do some research. And when I start doing my research, I can drag and drop these boxes with all the terms that I learn. And this is a very good way. This is a first law of software design. This is a good way to grapple or to grasp a domain and to start understanding it and the relationships between them. You'll see that I have no lines between them, and that's because that is the second law. The second law of software design is the humble line, and that's in video 2.
I'm going to watch that right now. So yeah, go give him a like and subscribe. He does awesome content, and he wants us to know about this stuff because it is actually super useful, and I'm very blessed to come across him and how he explains it so well. Again, give him some love, guys.
Hello, my name is Jonathan and welcome to part 2. This is software design from the beginning. So switching over to our view here, this is where we left off last time. What I've added is today's topics, the humble line, and we're going to discuss how the line fits in here. Now just before we do, I just want to point out that without lines, you can pretty much make a lot of cohesion and a lot of understanding about a system quite simply. And that's something that we can use to our advantage. Without lines, we can still reason and still make cohesion and relationships. By putting a boundary around these things, we understand that there's a relationship with these things. It might not be as clear as we need it.
I don't know what the quality is going on here. Hold on a second. Let me fix the quality here. Sorry about that.
It to be. It might not be as momentous as we need it to be, right? So the line can be an additional thing to understand. And what I'm going to do is I'm going to drag this out. Let's grab animal there and show how the relationship forms. So if I say that cat is an animal, I draw a line. I want to be careful not to confuse this with UML. I just want to draw a simple line. So,
yeah, no UML. He's like, don't think this is UML. Because UML has these strict rules, and some people who are familiar with UML will see it, go, "Oh, you're just doing UML, so it means this." Like, no, I'm not doing UML. Not doing UML. We are going to decide what it means. We're going to talk about what it means. If you don't know what it means, let's discuss what it means. Because the sooner we get to know what it means, the sooner we're going to be able to create the solution to the problem, because we're all on the same page. This is making sense?
So if I start drawing things like this, I am drawing a relationship between these things. Now, this relationship might be obvious or intuitive based on the labels or the text that we have on the box, but sometimes it might not be. So we might have to say that, a bear, and we might want to come in here and say, is an animal. Right, for example. And this is once again a form of a label on a line talking to the other box, right? So there's a relationship between these two boxes. Now, this kind of relationship sits at a level between two boxes, and that level seems adequate. But if I had to do something like that, I hope you can see that would seem entirely wrong, that seems inadequate, that this is not the right kind of thing, and probably because the level on which we're talking...
Well, maybe it could be, depending on the domain, what that meant. Maybe there was a reason to have that line there. But I think he says in this general example he's giving, in this context, it didn't make sense.
Right, the level of that object, and this boundary seems intuitively as if it is two different layers. So if I did something like that, one could understand, oh, that is a little bit more interesting. That does seem plausible, that a boundary for logistics and other things inside might have a relationship with trucks and vehicles. And if I had a boundary around this, you'll notice that the boundary relationship could make sense as well. So just by putting a boundary around that...
Right, the sense would be like, for our logistics program, we're going to be assigning trucks to animals because it's an ambulance, right? So a call comes in, we need truck number. Okay, we need an ambulance on at 911 Main or 101 Main. Okay, the guys. Okay, we need to assign a truck. Which trucks are available? This truck gets assigned to this potential cat or potential whoever, and whoever they get in the truck, they label them as a cat, and then that's all that stuff. So logistics does all that.
And dragging it there is more sensibility. Now this, to be fair, I drew it around this one first, and this one...
Logistics only in this context. It would be like some other thing if you're delivering packages or delivering something by drive. It'd be something completely different, right? So this is still just giving the idea of like, how do you arrange these things so people will understand.
It is kind of a haphazard kind of idea here. You can see that even internally, this boundary is not holding itself too well. We've got a thing, we've got a dog, we've got pets. It's not a very good sort of cohesive or abstraction. It's not very good. So let's change this completely. So if I had to say that we've got an animal, cat, and bear, we might want to bring all of this into the mix. I'm just going to move that over there. Bring that back and expand this out and say, well, there's the dog, there's the goat, and we're going to draw all of these things here and draw the relationship to the animal. And now you can see that that's going to make much more sense. Okay, just by using lines and boxes, we can have some kind of understanding. This isn't a software artifact understanding. I just want to point that out.
He means that there's no code here. It's just us trying to communicate ideas amongst each other. So when code happens, it'll reflect this shared reality.
I'm not drawing UML. I'm not doing object-oriented coding here. I am purely drawing boxes and labels and boundaries and lines.
Conceptual areas, things in our minds, like how we can separate these things out so it makes sense for what we're trying to do.
And so it's very, very simple to get an understanding of a system with this kind of basic elements, and that's why they are the first two laws. Let's talk about the line a little bit more. If I take the line and I say, well, to me, if I draw an arrow, it means something. Well, that could be the way that we formalize the line in some way. And that is in the direction of UML. So if I did something like that, it would mean something in UML. Is UML still used today? Absolutely. Is it worth learning? Absolutely.
I mean, yes, but then realize that whatever context you're in, you're going to have to redo it for whatever context you're in. And you're going to have to let people know, because they're not going to know UML. I'll guarantee you, people who you're working with that aren't technical or are working in the domain, they're not going to know what you're talking about with UML. So you have to help them along, and just, how about we go along together and we build it together. That's the best way.
Okay, that's debatable, by the way. Right, to me, UML still has a place. There are other types of illustrative kinds of things, and there's obviously this technique, which is very, very general. Let's have a look. So if I say that there's an animal...
Well, it's not general. It's we get to build it. We together decide what this means. and we'll only be working in this context for this project with this team. We decide what it is. We don't have to go to these other weird standards for this type of work, for this conceptual level. We don't need to be standard on anything because we're trying new things.
And I want to draw a thing, what I might do is have a relationship here from animal to thing. And now I've got some kind of relationship between that. If I say pet, I might want to say, well, this is a label. I feel that could be, a label describing that system. So the line is a very good tool for linking things that might also be within different boundaries. So for example, let's say I wanted to indicate whether a truck was required to move the animal. I could say, well, a bear over there is required for the truck. And if I had, some other kind of transport vehicle here, let's say I had a minivan, and I could say, well, the dog can go in the minivan, then I can start doing things like that. I'm drawing from here. Obviously, all of these things are linked to these vehicles. I can label it as a vehicle, but specifically, I can draw a mapping or a relationship between the bear and the truck, the dog and the minivan. And this might be a good way of reasoning between boundaries, but also within things between boundaries.
Yeah, very clever. I mean, not clever, but it's useful to know that you can do what these things mean. These things are putting things in conceptual boxes for people, and we can change them. We can move them around if the needs or the requirements change or something that doesn't sound right, or we got to do it a different way. This is the way to start and communicate about it. If you just use text, it's gonna fail. It's not gonna do it. It's not gonna do it.
The next kind of step I want to show you for the line is how you can draw the process. And really, it's quite simple. What we do is we draw a line and we draw a box on the line, right? So that's the easiest way. I'm going to neaten this up in a second. And what I can do is I can say, well, this is a line. The line travels through. There it goes. And at this point, this is step 1, this is step 2, this is step 3. And we often do things like this. We often draw lines to represent a flow. And you can see that because this kind of looks sequential and linear, you can kind of see some kind of flow without me really saying too much about it. It looks like a flow. And what I might describe in terms of this process,
or it could be 3 items that are just linked together. Okay, so we now know that he's interpreting this as a flow, as a thing that goes from another. Okay, as a sequence of operations, particular commands. Okay, now that we know that. Before that, we didn't really know, but now we know.
I might say that the bear is loaded onto a vehicle and delivered, for example. Okay, so in this kind of scenario, some kind of process points, and I can even link it from the bear. That's the wrong connection to make, I'm sure. I can draw that that's the bear there, or that's the boundary that it comes from, that the vehicle comes from this side, and delivered we don't have any concept for at the moment. And I can link this up. I don't have to link it up, but there you go. Just the line showing that you can. You can put arrows on this to point it in a certain direction to say that there is a flow. And obviously this leads into something more complicated like a workflow diagram, for example. The basics of any workflow diagram is a box and a line. Right.
Box events. This is okay. It's going to go from this one to this one to this one. You don't even have to say words for that. You can just look at it and know this is what this means, right? That's the whole point. So it flashes into our subconscious, which is our subconscious mind is visual. Some people prefer the auditory stuff, but our subconscious mind works in pictures. So when you do things like this, you immediately communicate.
Subtraction. So once you start building diagrams like this and they start getting fatter and fatter, once I've got a new concept over here, there's another concept and I've got another concept over here. Believe me, in any system, this is very easy to get to. Very, very easy to get to. Concepts like this grow tremendously complicated very, very quickly. And in this kind of strange scenario, it's better to actually say, well, that is that. So I'm going to remove it. In fact, that whole section here is a generalization of this.
So he's talking about the removing things. Right? The idea we can do, how about we simplify? Can we simplify? There's rarely someone on a team that has the guts enough to say, hey, maybe this design is overcomplicated. Maybe we could do a smaller piece of it. Maybe we could do a smaller piece right now, do that piece, and then we'll build on to the next thing. Or do we have to know all the details of everything, how it works? Or can we do an iterate? And then through that iteration, we learn about things that will help us design this thing better. That is the modern knowledge development process. Now, if you're working in other industries, there's certain ones you can't do that way. I'm talking about doing micro SaaS. I'm talking about starting your own business. I'm talking about working for small businesses and doing regional applications for verticals, that kind of stuff. You're going to need to know the domain to do that. And making out these diagrams is the bread and butter of how it's put together. And if you don't know, then you have to go through the iterative knowledge process of trying out something with the best you have now. You try it out, and through that, you will discover something that may get you, that usually, if you're lucky, will get you to the next thing.
So I'm going to remove it.
So I'm usually the guy that says, "Can we simplify?" I will usually take the hit, and I'll take the hit, but the results will speak for itself. If we have something that gets us further down the road, I usually don't get credit for that, but oftentimes we will, and I'll just be okay. We just learned something, and I'm not going to bring it up. I'm not going to say I told you so, but I want to bring that flavor of like we're not going to know this stuff ahead of time, and to think that we do know it ahead of time is bravado and unheeded caution.
This has a relationship here, that's fine, but these things can be abstracted away and I can remove it. So the act of removing or subtracting things, saying that, we don't need a bear anymore, forget the bear, let's take the bear out of the equation, we're only going to move a dog, for example, you can see that I'm simplifying. And simplification is very, very important. So
very, very, like, the tendency for developers, for especially technical people, wanting to like push their technical limits without understanding the edge conditions and edge cases, it's such a nightmare. And a lot of these guys will just not admit, hey, you didn't think about this part, did you? They will never say, it's like, no, well, it's just we need to optimize the algorithm. It's like, no, you didn't set it up right. We have to go back and redo it, and that's fine. This is normal part of the process. But don't gnash teeth with, I know it already. It's like, that's the word. Man, so many failed projects from that attitude.
The line represents the connections between different boxes and boundaries, even labels to be more accurate. The line suggests the relationship. The relationship can be dictated in any manner that you choose. You can draw a dotted line, a dashed line, you can draw an arrow on both ends. The way that you draw those things means something to you, and you can decide what
you and your team and the people you're working with. We get to decide what they work, and for that particular diagram as well. Other diagrams may have other meanings.
That means the line symbolically also.
What does it represent?
Represents subtraction and how important it is to actually remove things from the first step. In other words, removing boxes. So if I have too many boxes and I have to distinguish between those things, I can have a terrible time in code. It is very easy to get carried away within an illustrative kind of model like this, right? When you're thinking and designing and trying to figure things out, it's very easy to get lost in it.
It's so common. Once people get into this stuff, they go, let's go nuts. It's like we're trying to communicate particular ideas, not every idea, not everything possible. That's a recipe for disaster, right? I'm gonna map out all details in advance. I will not fail this time. It's like that's a total recipe for disaster. Now you do have to plan up front. You do have to think about these things, but maybe do a prototype, another prototype, and then do it instead of trying to build the thing right from the start that does all the things.
Keep adding to, oh, what about that? Oh, what about this? And just keep moving ahead without sort of taking into account whether it's really required or not. So you have to check yourself. Every so often you have to go in and say, do I need X? Am I going to?
And there may be one where you create the master diagram and then we take pieces out and communicate those pieces in smaller bite-sized chunks, so people can understand your master vision.
Too far. What checklists you might have would determine perhaps what kinds of things you have. So requirements, for example, some kind of requirements checklist. Other forms of checklists as well. We'll get that into that in another video. Okay, so that's very, very important. So the quick recap of episode 1 and 2 is that we have a box. A box represents things. We can use them to reason about lists of things within a domain. The domain language, well, we should try and keep to a domain language or whatever we're talking about. We can list those things. We can draw them cohesively inside of boundaries. We can link them with lines and draw relationships between them. This formulates the most fundamental parts of software design. We're going to look at abstract things next. So we're going to look at what these kind of things.
We're going to make some general stuff next. Oh, okay.
Might mean what generalizations could be implemented and that sort of abstract nature. And then in episode 4, we'll go back down to earth and talk about the.
Okay, let's look at one more. I promise this is the end, and we'll move on from here. But you should watch his whole series. It's really great. Go and give him a like and subscribe. Jonathan Crossland, genius level stuff here, especially for beginners and for anyone involved with software development in general.
Hi, my name is Jonathan, and welcome to Software Design from the Beginning. Right, episode 1 we discussed the box, episode 2 the line. Now it's time to kind of bring them together in a little bit more abstract thought. So what I'm going to do is get rid of all of this on our board, and I'm going to start again. Let's go and just get rid of all of this, and we're going to start thinking about abstract design.
Ooh, right. General. Ooh, abstract. It sounds so cool. We're an abstract design. No, it's just the general overview. Okay. Computer people.
Okay, so here we have a box. Let's put the box down. I'm going to draw it elongated. I'm going to draw it as a rectangle. I'm going to stretch it all the way around. As I do this, it gives you a sense of what it might be, right? Because it's pulled wide. What do you think that might be? It's width, right? So design width. If I'm thinking width, if I draw something like that, it's quite tall. If I draw something like that, it's wide. Words that we think of when we draw something wide is a layer or a foundation, a platform, and so on. So what we're really saying is that it's the foundation or the infrastructure or something that something else builds on top of. So if I build something like that, you will instinctively, with only a year or so into software, perhaps even less than that, understand what this would be. I mean, you're going to see things like this drawn all the time, and this is a form of the box. But what is it doing? Well, it's suggesting as soon as it gets elongated like that, intuitively we just think, oh, foundation, and therefore it must be an architectural diagram, right? I mean, this is baked into, I think, into many of our kind of ways of thinking already. Everybody goes to this kind of level of understanding, perhaps intuitively. Perhaps you didn't think too much about it, but there it is.
This is like this pattern here is very common. Now, you can go from the bottom to the top or the top to the bottom, but this whole thing is like extremely common, and it's like gives you like an overview, but the specific details of how it's implemented on these different diagrams is always domain specific. So it's like it's helpful. It's like here gives like an overview of like where we're going with this thing, but the implementation details you gotta get either more diagramming or then textual description to even more detail level, which is basically code.
I could do this and say, well, this is the CPU. I might come in here and I say this is hex, you know, and I can draw layers. And this really is the fundamental way of illustrating an abstraction, right? Or what we can call layers.
Layers of abstraction. You mean general layers? Layers of like general concepts? Oh. No, it's layers of abstraction.
Of abstraction. So what does that mean for us when we're designing and when we're doing things? Well, fundamentally, and it's quite neglected, I feel, fundamentally, we should be building layers upon layers on where we're going, right? So we're starting at this point and we're ending up somewhere over here. And what that is might be something like MVC. Let's say you're building a web app or a desktop application, and you know, you've heard of MVC.
The model view controller is just a style of creating an application. Model means data. The data. Oh, the data. The view is the display where it prints out, or on a printer, or on a monitor somewhere. And the controller, which is just goes back and forth. The controller grabs the data and puts it on the screen. It takes the message from the view, right? Any buttons are pressed, and takes the controller. Then goes and puts data out on the network or puts it in the database. Ooh, it's a model view controller.
MVC, and you might even have a technology called MVC, and there it is, and you build on it. Well, what's underneath that? Well, if we go deeper, we might say, well, underneath MVC is some kind of pipeline. Where does that pipeline come from?
Pipeline. It's a pipeline. I mean, stuff that gets in and out through something. So you have a pipeline from the network where the data comes in and goes to your application. It's a pipeline.
From? Well, the pipeline is built into a web server, for example. Well, what does the web server do? Well, the web server is a listener, and it's listening for messages, and the messages are HTTP. So you might say that this is a message, not really a platform, that the message comes into the web server.
And HTTP is just like it's a protocol, a standard, a way of sending messages in and out of the computer. Hypertext messages, hypertext transport protocol. So it's just a way. It's like, okay, if I'm an application, I need to get a certain page. I send an HTTP request. I send a message that says, "Give me that page," and it goes to the server. Server gets the message in. The function gets called, generates that page, or goes looks up in the database and sends it back. An HTTP request fulfilled. So the HTTP just has a from. It's just a little piece of data structure memory. It says from, to, and then the message. Some random data, whatever the application needed. If it's a web server, it's serving HTML. When it's serving web pages, it's going to serve back a string of characters. That's HTML format. It was a hypertext markup language. This stuff is so so silly. It's just the standard for sending what a page is going to look like. Okay, wow.
It goes through the pipeline, ends up on your MVC. Well, what's happening now? Well, from that MVC, you're now doing your own thing. This is your domain. So let's just change color here, right, just to represent that it's your thing. And this is the platform that you're building on. And the HTTP message comes through. Well, what have you got here? Well, you might have a controller. This is your controller, and you might.
And that yellow color he picked is not standard. It's just for our conversation when we're talking right now with him. That's what it means. But in general, it can mean anything, right?
Have some kind of data layer, right? You might have some kind of business layer, right? These are
business layer. Oh, okay. So if somebody comes in and checks in a book, you check to see if they've got a fine, and you fine them if they got late fee and don't let them check out stuff. That's the business layer. The controller actually talks to the system code, but the business layer talks to the controller to tell it like, okay, this book structure needs to be checked in, or business layer.
Common terms for layered architecture in, I think, well, it's pretty common. It's pretty common. So what we might do is say, well,
this is like your application, like what it's doing. If you're learning a library, you're checking books in, you're registering users, whatever, but that still has to go through the controller. It sends the messages to the MVC, that then sends it to the pipeline, to the network, that sends it to the other server someplace else, that through it via an HTTP request, which is a packet of information that just says, hey, here's what I want. And the server says, oh, okay, I got that, or I don't got that. If I got it, it sends it back. If I don't, it sends back an error message. Woo.
Here's a controller.
But it is good to have these things separated out so we can talk about, what are we talking about? Are we talking about like the servers on some other servers messing up somewhere? Is the pipeline messed up? Does the network broken? Do we need more pipes out for some reason? Is this the right pattern to be using for our application, the MVC pattern, or should we use something other library?
Controller talks about business layer,
kind of stuff.
Talks about data layer, right? It might be something like that. Well, how do you relate this kind of diagram in boxes? How do you relate this to the cat, for example? Right? There's the cat. Let's draw that as another object. So the cat there is an object. So in an MVC, what it resides it to is a model. So this concept of a model view controller, this would be, let's say, representative of a model.
The cat, the data structure for a cat. Oh, so it represents the cat in memory. So the cat has a name, has a weight, eye color, fur color. It's representing a cat. It's not a cat. It's representing a cat. It's a piece of memory somewhere that's just representing what this cat in the system is. It's not actually a cat. It's representing a cat.
We'll get into complications of this later on, but really, ultimately, for now, we're going to say, well, look, the HTTP message comes through. There's the message. And I'm going to draw this as green to represent things that are not in our control. Okay, so these things here are part of the platform that we are building on. And the HTTP message comes through, and it lands in our controller, and the controller has to understand the cat, and there is some kind of logic and process and flow, and there comes the cat.
Yeah, like if we're doing cat transport, it has to assign it to a vehicle, assign it to a driver, schedule it, etc. Whatever the domain is. Yeah, that's what you're talking about.
Right. Now, in different paradigms, right, software design, software paradigms.
Ooh, a paradigm. Ooh. It's just a style, a way of doing something. A paradigm. No, it's not a style. What are you talking about, style? We're getting serious here with a paradigm. It's just how you think about something, right? How you think about something and how you do something. The paradigm. It's like the methods involved. Ooh, it's a paradigm.
Like object-oriented or functional programming or service-oriented, that kind of thing, component-based architecture and so on.
Those are just names for techniques and styles. They're not actual things in themselves. They're just ways of structuring things, ways of conceptualizing a problem. No one's better than the other. Some could have an easier approach. Some has a more difficult approach. It really depends, right? It depends on so many factors. A lot of this comes from experience. A lot of this comes from just trying it out one way and then like, that didn't work. Try something else.
We look at a cat would differ, right?
And hopefully you don't run out of money.
How, what we reason about this cat and where it lives in the database, or how it's stored in memory, or how it's located and how it's delivered, we might subtly, with various kinds of attitudes and modern ways of thinking, reason about this differently. Right. So some might say, well, the only way to describe this should be by using some kind of relationship here and saying, I don't want to do UML, right? I just want to do that. Not that an arrow is UML, it's just that it might be confusing. So here.
Mm-hmm. Right. And the reason why it could be confusing is because people will program for a while there. UML is the only way. It's like, no, the idea of UML is like, okay, can we have a system we can devise? And that's what his point here is. Like, we decide, we define this system. This is the work. This is the knowledge work. It's this stuff. The coding typey. And yes, it's important. You need to know how to do all that stuff. It's why we're doing this stuff. Is we're kind of the people that can do that kind of stuff. But this is the work. This is more of the work because we can make our lives difficult. We can make our lives easy by how we set up the problem. 80 IQ points. How we set the IQ problem. Are we going down, flowing with the problem, or are we flowing against the problem?
Here I have a line. And this line is a relationship. And how do we express this relationship? Well, in code, we might express it as inheritance or something of that nature, or with an interface or something like that. But ultimately, from an MVC standpoint, all it really wants is a model that it then gives and provides to a view. And this kind of understanding of cat and animal in terms of interfaces or classes or how we reason about that data is really the connection between the cat as a domain languaged object, meaning, let's do this differently. So if the blue represents the domain, right? If you've got the domain experts in a room, and you put them all together and you came up with a domain model of their industry, they are not thinking of inheritance. They're not thinking of composition. They're not thinking in object-oriented terms or service-oriented API. It's a
Correct. They will not. They are not interested in learning as well. Do not force them to learn your stack. They're not interested. They want you to learn their stack, and you can learn their stack because that's the kind of people we are. We can learn other people's domain. It's fun. If you don't enjoy learning other people's domains, you're not going to like this work. You're definitely not going to like this work. But if you like working with other people and figuring out how they do stuff and their ways of thinking about things and maybe improving them or like becoming aware of some other viewpoint, that's the fun part of this job. The typey stuff is kind of semi-annoying. Some people really love the typey, and some people hate this, and then other people like this part, and they don't like the typey. I like all of it. I mean, I can deal with all of it. The typey stuff gets a little annoying sometimes, especially when the technology stacks keep changing so rapidly. But if once you get proficient, it's actually pretty fun, and that's not the barrier anymore. And that's this stuff, this conceptual layers and communicating ideas with each other effectively.
Different type of thing. That's an abstract concept. What they're talking about is the relationship between the cat and the vehicle and transport and process. So really, they're going to be talking in a different type of language, and perhaps these lines mean something entirely different to them.
Right.
And this is an age-old kind of scenario here. How do you kind of map these two things? How do you map the design that they are giving you from a domain standpoint into what you would consider a design in a technical domain standpoint? And so, they can be the same thing in a sense. They can relate to each other. One person could reason about both these sides and do it. But as you get in larger domains with a lot more technicalities and complexities, you're going to have professionals doing this, and you're going to have to translate it somehow into something like that. So this is
that is a skill, and you can only acquire that skill by doing it. So toughen up, buttercup, because this is the work.
Is an abstract concept. So just to review this, just to be clear, what I'm saying is that the box also represents architectural type of things, something like a layer. If you think
architecture meaning how we build the thing. That's all it means. How are we going to build this thing? What are we putting in here? Are we building a house? Are we building a trailer? Are we building a skyscraper? Are we building an office mall? Are we building a subway sandwich shop, or actual subway? That would get confusing, wouldn't it? Yeah.
Think in layers and you think in technical terms here, this is a different kind of level of thinking than this. And this is a different level of thinking than that. There are 3 steps here. In fact, if we went further and said that our architecture, this is a very, very basic form of architecture. What we actually would like is something else. We would like some kind of API over here.
Ooh, it's an API. Ooh. Application program interface. Oh, you mean like functions that you call some library somewhere that somebody else wrote, and I just call and get the information that I want back? No, it's not a library. It's an API. It's not functions. Oh, but isn't just you call a function and gives you calling something and gives you the stuff back? It's not that. It's not. It's more complicated.
Here. And perhaps it is shared and the controller talks to an API. Perhaps the model viewer controller, the actual view that sits there. Perhaps
I think they want it to be more complicated. I think that's why they have to add all this junk, this inconsequential stuff like, oh, it's an API. It's like, okay, it's a library functions on a web server. Okay, why do you have to make it bigger than harder? This is already hard enough. This is already just doing this stuff is hard enough. Why do we have to add to it? It's computer people. They gotta.
Talks to the API itself. Let me do that. Create a view. You can see how complicated this could get, right? Because now we have these layers talking to layers, and there is a generalization of layers. But there is also the concept of generalization of our objects. Okay, and I find that this is often some kind of stumbling block.
He says objects here, but he means his classes. But we'll get into all what he means by that. What those particular terms mean. But okay, I'll let it go for now. I'll allow it.
Or perhaps, to be fair, I should say, people don't really reason about the three. They tend to reason about the one and then try and shove it into something that they've already got here. So architecture and good design, from my point of view, would be to understand very clearly what these three things are actually about, what they are requiring, and have a decent connection, a decent generalization, having a form of understanding of all three that is very cohesive. We then try and...
Agreed. And we can only do this through meetings and talk about it in diagrams like this. If you try and do it with just text, it's not going to work. You have to do stuff like this.
Simplify. We have constraints now and technical capabilities as well as business capabilities to fulfill. So lastly, I'll point that out, and then we will go to the next episode and talk about checklists.
So I'll let you go look at that. Thank you so much, Jonathan Crosland, for doing that. Next up, we're going to be getting into... What was this one? We just watch this one? Okay, yeah, I think we just watched this one. Episode 4. Episode 3, episode 4. I'm gonna let you go watch episode 4. Super useful to know. I might cover it in the next video, but this has already gone on an hour. So like and subscribe me, and we'll continue the next video.